Alright, let's take a look at these two questions. They both deal with reflections, which you can think of as flipping a point or a shape over a line, like looking in a mirror. In the first question, we are asked to find the image, which is the new position of point K when it is reflected across line N. Think of line N as our mirror. Usually when we reflect something, it appears to the other side of the mirror. So, let's have a look at point K. Where is point K located? If you look closely at the diagram, point K is sitting exactly on the line N. Here is a golden rule in geometry. If a point lies directly on the line of reflection, it doesn't move. Now imagine pressing your finger against a mirror. Where is the reflection of your fingertip? It's right there at the same spot. Because K is on the mirror, which is line N, its image is itself. So the image of point K is K. Now, let's look at the second part. We are given point Q, 8 and -5, and told that point N is its image after reflecting over the x-axis. When we reflect a point over the x-axis, or the horizontal line, the point stays in the same left-to-right position, but it flips from bottom to top or top to bottom. The x-coordinate, which is the first number, stay the same. The y-coordinate, which is the second number, becomes its opposite, which means you change the sign. So our original point Q is 8 -5. Since we are keeping the x, so 8 stays exactly as it is. Now flip the y. The -5 becomes its opposite, which is +5. By keeping the x and changing the sign of the y, we find the coordinates for n, which are 8 and 5. See you in the next video. Alright, let's dive into this geometry question. We are looking at a reflection, which is basically a flip. Imagine placing a mirror right on the x-axis. We want to see where our points land on the other side. First, let's look at what the question gives us. We have a line segment PQ with endpoints P at -4, 7 and Q at 11 -5. We are reflecting this segment about the x-axis. We need to find the coordinates for point N. Since the question says N is the image of Q, we only need to focus on what happens to Q. When you reflect a point over the x-axis or the horizontal line, the point stays in the same spot, but it flips its position top to bottom or bottom to top. In math terms, the rule is, the x-coordinate stays the same, while the y-coordinate becomes its opposite. In other words, it changed the sign. Now let's take our point Q and apply that rule to find its image, N. Point Q is 11 and -5. By keeping the x, so 11 stays exactly as it is. The y value is -5. The opposite of -5 is +5. So point N is at 11, 5. A quick way to remember this is that if you reflect across the x-axis, the x stays the same. If you were reflecting across the y-axis, the y would stay the same. See you in the next video. Alright, let's take a look at these reflection questions. Think of a reflection just like looking into a mirror. The mirror line, which is our axis, is where the glass is, and the image is the same distance away on the other side. Let me show you how to find the coordinates when reflecting on the x and y axis. For part A, we are starting with the point 6, -4. The question says we are reflecting about the x-axis. This is the horizontal line running left to right. When you reflect across the x-axis, the x-coordinate, which is the first number, stays the same. However, the y-coordinate, which is the second number, switches its sign. Positive becomes negative, and negative becomes positive. For the given coordinates, 6 and -4, the x-coordinate is 6, so it stays the same. Now the y-coordinate is -4, therefore, this changes to 4. So the coordinates for the image is 6 and 4. For part B, we are starting with the point -8, 5. This time, our mirror is the y-axis. This is the vertical line running up and down. When you reflect across the y-axis, the y-coordinate, which is the second number, stays the same, while the x-coordinate, the first number, switches its signs. So, the x-coordinate changes from -8 to 8, while the y-coordinate stays 5. So the coordinates for the image is 8 and 5. If you ever get stuck, just remember this. Reflecting over the x-axis? Change the y-coordinate. Reflecting over the y-axis? Change the x-coordinate. See you in the next video. Alright, let's take a look at this geometry question together. It is all about reflections. The question tells us that a triangle PQR is being reflected to create a new triangle, triangle P', R', Q'. To solve the missing coordinates, we first need to figure out where the mirror line is. We can find this by looking at point P and its reflected image, P'. The original P coordinates are at 10, -8, while the image P' is at 10, 8. Notice that the x-coordinate 10 stayed exactly the same, but the y-coordinate changed from negative to positive. When the y value changes sign like this, it means the shape was reflected over the x-axis. Since the entire triangle is reflected the same way, the rule we found for P must also apply to Q. This means we keep the x the same and just flip the sign of the y. Now let's look at the original coordinates for Q, 14, -3. Applying the rule, keep x the same, the 14 stays 14. Flip the sign of y, so -3 becomes a positive 3. So the coordinates of Q' are 14, 3. Whenever you see a reflection problem, always compare the original point and the image point first. If the x stays the same, it is an x-axis reflection, so y flips. If the y stays the same, it's a y-axis reflection, so x flips. Thank you for watching and see you in the next video. Alright, let's take a look at this geometry question together. We are being asked to find the image of a triangle after it has been reflected across the x-axis. Think of a reflection like looking in a mirror. The x-axis, that horizontal line in the middle, is going to act as our mirror. First, we need to find the coordinates x and y of the three vertices of our original triangle, A, B, and C. Point A, go right 3, then up 5. So A is at 3, 5. Point B, go right 1, then up 2. So B is at 1, 2. Point C, go right 4, then up 0. So C is at 4, 0. When we reflect a point over the x-axis, the horizontal position, x, stays exactly the same, but the vertical position, y, flips to the opposite side. To reflect over the x-axis, you keep x and change the sign of y. Now let's apply that rule to our 3 points to find our new vertices, which we usually call A', B', and C'. For A, our coordinates are at 3, 5. Keep the 3, but change 5 to -5. So, our new point A' is at 3, -5. For B, our coordinates are at 1, 2. Keep the 1, but change 2 to -2. Our new point B' is at 1, -2. For C, our coordinates are at 4, 0. Keep the 4. Since the opposite of 0 is still 0, this point stays exactly where it is. Our new point C' is at 4, 0. Perfect. Those 3 points create the mirror image of the triangle below the line. See you in the next question. Alright, let's have a look at this geometry question. It's all about visualizing how shapes change when we fold and unfold them. First, look at the rectangular paper. It's folded right down the middle, the vertical line. When we fold paper like this, the fold line acts like a mirror. Anything we do on one side of that fold will be perfectly reflected on the other side once we open it back up. Now look at that dotted line where the cut happens. It starts 8 centimeters up from the bottom corner on the fold line, and it ends 6 centimeters away from the fold line along the bottom edge. Before we unfold it, the piece we cut off is a simple right triangle with a height of 8 centimeters and a base of 6 centimeters. This is the most important part. Imagine unfolding that small triangular piece. The vertical side, the 8 centimeters part, is right on the fold. It doesn't change. It stays the center spine of our new shape. The bottom edge was 6 centimeters wide on the folded paper. When you unfold it, you get another 6 centimeters on the other side of the fold. So the total base would be 6 centimeters, left side plus 6 centimeters, right side equals 12 centimeters total. So, what shape do we have when it is opened? The two slanted cut lines will be exactly the same length, because they are reflections of each other. Therefore, by unfolding the paper, we doubled the width of our base, but kept the same shape symmetrical. So, the unfolded piece is an isosceles triangle with a base length of 12 centimeters. See you in the next question.